Hello everyone, I'm going to go ahead and go through lesson 5.3, solving radical equations today. So when we're trying to solve radical equations, the first thing we want to do is isolate the radical on one side of the equation. So we want to get the radical all alone, then we'll raise each side to the same power to eliminate the radical. We'll solve and we'll check our answer because we may have some extraneous solutions. So we're just going to jump in. So the first thing we want to do is we want to get the radical alone, which means I need to get rid of this 3 out front. So I'm going to need to go ahead and divide both sides by 3. So I'll get the square root of x plus 2, because this 3 and this 3 will cancel, equals 6 divided by 3, which is 2. So then I need to get rid of the square root. So what I'll do next is I'll raise both sides to the power of 2 to get that to cancel. So I'll square this side and this side. So when I square that, the square and the square root will cancel, and I'll get x plus 2 equals 2 squared, which is 4. And then the last thing I need to do is subtract 2 from both sides. So I'm going to get that x equals 2. And then finally, I need to check for extraneous solutions. So I'm going to need to go ahead and plug back in to see if I got something that didn't work. So I plug into the original. This is my check. And I do 3 times the square root of 2 plus 2 equals 6. 3 times the square root of 4 equals 6. Well, the square root of 4 is 2. 3 times 2 does equal 6. So we are good to go there. This is not an extraneous solution. So this would be our answer. Okay, so the next problem, again, the radical is not alone, so we got to get that radical alone first. So we'll start by dividing both sides by 5. We'll get that the square root of 3x equals 15 divided by 5, which is 3. Again, I want to get rid of that square root, so I'll go ahead and I'll raise both sides to the power of 2. I do that so that the square and the square root will cancel, and I'll get that 3x equals 3 squared, which is 9. And then I'll divide both sides by 3. So I'm going to get that x equals 3. And again, I do still need to check. So I'm going to plug 3 back into the original. So I'm getting 5 times the square root of 9 equals 15. Well, the square root of 9 is 3. And 5 times 3 does equal 15. Okay. So this problem has some other stuff out front of it. So instead of dividing this time, we need to move that 7 over. So we'll start by subtracting 7 from both sides. But then we still have this negative sitting out front, which we don't want. So we need to go ahead and get rid of that negative. And to do that, we're going to divide both sides by -1. Because dividing both sides by -1 is going to get those two negatives to cancel. So I'll get the square root of x minus 4 on the left side, and I'll get 13 on the right side. So then again, to get rid of that square root, I'm going to square both sides. So the square root and the square will cancel. So I'll just get x minus 4. And from our list, 13 squared should be 169. So then I'll add 4 to both sides. And I'll get that x equals 173. But again, I have to check it. And I'm plugging into the original. 173 minus 4 equals -6. So 7 minus 173 minus 4 is again 169. The square root of 169 is 13. And 7 minus 13 is -6. So I am good to go. Okay, moving on to the next one. So this is a cube root, but we're going to do essentially the same thing. So we're going to start by isolating that radical. So we'll subtract 1 from both sides. So we'll say the cube root of x equals -3. And again, we'll raise to the power, but this time instead of squaring it, we're going to raise both sides to the third, because that cube and that cube root will end up canceling now, and that'll give us x on the left side. And -3 cubed is actually going to be a -27, right? Because -3 times -3 is a +9, times another -3 is a -27. And then again, we do have to go back and check it. So I'm taking the cube root of -27 and adding 1, and I want that to equal -2. We can take the cube root of a negative number, and a cube root of a negative number just means it's going to be negative. And the cube root of 27 is 3. So -3 plus 1 is -2. So we are good there. This would be our answer. Okay. We have another cube root here, but this time it's kind of nice because that cube root is already isolated, right? That cube root is already alone on one side of the equation, so we can go ahead and we can just raise both sides to the third power. So when I do that again, that cube and that cube root are going to cancel, so I'll get 2x plus 7 equals 5 to the third, which again is from our list, so it should be 125. I'll subtract 7 from both sides. So I should get that 2x equals 118. And then I'll divide both sides by 2, and I should get that x equals 59. Okay, and then again, I do want to still check it. So 2 times 59 plus 7 should equal 5. 2 times 59 is going to be 118 plus 7. 118 plus 7 is 125. I'm sorry, this is a cube root. Drop that. Got to be careful there. And the cube root of 125 is 5. So we are good here. The check worked. Okay. So when we have two square roots like this, one on each side, the nice thing about this is, again, we can go ahead and we can start by raising both sides to that power. So we can start by squaring both sides. And when this happens and there's nothing else on the outside of the radical, nice things happen because the square and the square root cancel, and we just get x minus 3 on one side, and the square and the square root cancel, and we get 2x minus 7 on the other. So we'd subtract x from both sides, and we'd add 7 to both sides. So we're going to get that 4 equals x. Okay. But again, we still do want to check to make sure that this worked out the way we wanted it to. So we're going to do the square root of 4 minus 3 equals the square root of 2 times 4 minus 7. So 4 minus 3 is going to be the square root of 1. 2 times 4 is going to be 8. 8 minus 7 is 1. So we'd get that 1 equals 1, which it does. So we're good to go there. Okay. I'd like you to try this one on your own. Okay, again, this is very similar to the last one. We have both fourth roots on either side. They're already isolated. There's nothing else going on. We can go ahead and we can raise both sides to the fourth power. And so that fourth root and that fourth is going to cancel. So we'll get 3x plus 3. And again, fourth root and that 4 will cancel. And so we'll get 2x minus 7. So we'll subtract 2x from both sides. And we'll subtract 3 from both sides. So we'll actually get that x equals negative 10. Oh, just kidding. I don't want you to try this on your own. Okay, so then we're going to plug back in because we do want to check to make sure it works. So we're doing the fourth root of 3 times negative 10 plus 3. And we want that equal to the fourth root of 2 times negative 10. Minus 7. So 3 times negative 10 is going to be negative 30 plus 3 is a negative 27. And 2 times negative 10 is a negative 20 minus 7 is a negative 27. Now, we do technically have the same thing on both sides, but can I take the even root of a negative number? No, I can't, because this is going to end up giving me something imaginary. And imaginary is not allowed, so this is actually extraneous. So there's actually no solution to this problem. And that's why we check. We want to make sure that we are not taking the even root of a negative number. So even though these are the same, that check still does not work because we don't want imaginaries there, so there is no solution. Okay. The next one's a little tricky too, because we have two radicals going on, but we actually also have this plus 1 happening, which kind of ruins things a little bit for us. So when we have something like this, we're going to start by getting one radical alone, squaring, and then going from there. So right now we have this 3x minus 3 that is already alone. So we're going to go ahead and we're going to square both sides to try and get rid of that first radical first. So I'm going to square both sides. So the left side is nice and pretty because the square and the square root, the right side is nice and pretty because the square and the square root will cancel, and I'll get 3x minus 3. The left side is where things get just a little bit gross because this is really the square root of x plus 1 times the square root of x plus 1. So I am going to need to do the box there. So I have the square root of x plus 1 times the square root of x plus 1. So the nice thing is the square root of x times the square root of x is just going to be a regular x, right? Because the square root times itself kind of cancels that square root out. This would be 1 square root x. This would also be 1 square root x. And 1 times 1 is 1. So we're going to get x plus, we can combine these square root x's together, so it's going to be 2 square root x plus 1. Okay? So we got rid of one radical, but now we got to repeat our process. So we got to isolate this radical now and then square both sides again. So that's what we're going to do now. So I'm going to subtract 1 from both sides, and I'm going to subtract x from both sides. So I'm going to get 2 square root x equals 2x minus 4. I still have that 2 out front, so I do want to get rid of that. So I'm going to divide both sides by 2. So dividing every single piece. So that's going to get rid of that 2 out front. So I'll just get the square root of x equals 2x divided by 2 is going to be x, and 4 divided by 2 is going to be 2. Okay, so now I can go ahead and I can square both sides again to get rid of that other radical. So this time the left side is going to be pretty, and I'm going to get x, while the right side is going to be a little bit grosser. And I am going to have to do the box for that one as well. So I'm going to get x minus 2 times x minus 2. So x times x is x squared. X minus 2 is negative 2x. X minus 2 is negative 2x. And negative 2 times negative 2 is 4. So on the right side, I'm going to get x squared minus 4x minus 4. And this is a squared, so I am going to have to get set equal to 0 and solve from there. So I'm going to subtract x from both sides. So I'll get that 0 equals x squared minus 5x minus 4. And you guessed it, we're going to have to do the box again, but this time the other direction. So I have x squared and negative 4. So I want something that multiplies to negative 4x squared, but adds to that middle term of negative 5x. It's going to be negative 4x. Oh, I'm sorry. That's wrong. It's going to be, oh, wait. Oh, I'm sorry. This is a positive 4. I was like, I definitely did something wrong. This is meant to be a positive 4. That's why. So we want something that multiplies to a positive 4, but adds to a negative 5x. So it is negative 4x and a negative 1x. So out of the first column, I can take out an x. Second column, I can take out a negative 4. First row is an x, and second row is a negative 1. So we'll get that 0 equals x minus 4, x minus 1. And we would set each of those equal to 0 and solve. And so our two possible answers are going to be 4 and 1. But wait, you guessed it, we do have to check. So we are going to go ahead and we're going to plug back in. So this is our check. So we're saying for the first one, the square root of 4 plus 1, plugging into the original, is to equal the square root of 3 times 4 minus 3. So the square root of 4 is 2. 2 plus 1 should equal 3 times 4 is 12 minus 3 is 9. So 3 should equal 3. It does, so 4 is an answer. And then we also need to check 1. So we'll say square root of 1 plus 1 needs to equal the square root of 3 times 1 minus 3. And so we'd get 1 plus 1 needs to equal, well, 3 times 1 is 3, minus 3 is going to be 0. So 2 does not equal 0, so this answer would be extraneous, and just x equals 4 would be our only possible answer there. Okay. Alrighty. Okay. So our only answer there is x equals 4. Okay, we got 2 more. Yep. So next one, again, we have that radical already isolated. So we're going to go ahead and we're going to square both sides. So on the right side, that's nice and pretty. We'll get 2x plus 7. But on the left side, we are going to have to do the box. So I'm going to do x plus 2 times x plus 2. So x times x is, okay. So, started this one but haven't finished it yet. So what we're going to do now is, again, we already have this radical isolated, so we can go ahead and we can square both sides. So on the right side, that's going to be nice and pretty. We'll get just 2x plus 7 because that square and that square root cancel. But on the left side, we are going to have to go ahead and do the box. So we'll do x plus 2 times x plus 2. We'll get x times x, which is x squared, x times 2, which is 2x, x times 2, which is 2x, and 2 times 2, which is a positive 4. So on that left side, we'll get x squared plus 4x plus 4. So we don't have to square again, which is nice on this one. But again, we have an x squared, so we're going to have to get everything equal to 0 and solve. So I'm going to subtract 2x from both sides, and I'm going to subtract 7 from both sides. So I'm going to get x squared plus 2x minus 3 equals 0. And then I will have to do the box again, but this time to factor. So I'm going to say x squared and negative 3. So I want something that multiplies to negative 3x squared, but adds to that middle term of 2x. So that's going to be a positive 3x and a negative 1x. So out of the first column, I can take out an x. Out of the second column, I can take out a 3. First row would be an x, and second row would be a negative 1. So I would say x plus 3, x minus 1 equals 0. And then again, I'd set each of those equal to 0, and I'd solve. So my two possible answers are negative 3 and positive 1. So then I need to go ahead and I need to check those. So let's start with negative 3. So I'd say negative 3 plus 2 has to equal the square root of 2 times negative 3 plus 7. Well, negative 3 plus 2 is going to be negative 1. 2 times negative 3 is negative 6. Plus 7 would be a square root of 1. So negative 1, does that equal the square root of 1? It does not. So this one would actually be extraneous. And then I also need to check 1. So I would say, okay, 1 plus 2 would equal the square root of 2 times 1 plus 7. So that's going to be 3 equals 2 times 1 is 2 plus 7 is 9. 3 does equal the square root of 9, which is also 3. So our only answer would be x equals 1 there. All right, last one. So again, we have two sets of radicals here. We already have one isolated. So I'm going to go ahead and I'm going to start by squaring to get that one canceled out from the get-go. So I'm going to square both sides. So on the left side, I'm going to get the square and the square will cancel, and I'll get 2x plus 3, which is nice. On the right side, we're going to do the box, and it's going to be kind of a funky box because what we're actually squaring is 1 plus the square root of x plus 1. That whole thing is just like one term times 1 plus the square root of x plus 1. So we need to be careful there. So 1 times 1 is 1. This box would just be the 1x square root of x plus 1. This would also be 1 square root of x plus 1. And the square root of x plus 1 times the square root of x plus 1 would, again, those square roots would cancel, and we just get x plus 1. So I'd get x. I can combine the ones to be, I can get x, and then I can combine the two square roots to get 2 square root of x plus 1. And I can also combine the ones to get plus 2. So now I have to isolate the other side. So I need to move everything over to one side. So I'm going to subtract x from both sides. And I'm going to subtract 2 from both sides. So when I do that on my left side, I'm going to get x plus 1. And on my right side, I'm going to get 2 square root of x plus 1. Now, we would go ahead and divide by 2, but then I'd be dealing with fractions, and fractions are kind of gross. So if I can avoid fractions, I want to. So what I'm actually going to do is I'm going to go ahead and I'm going to square both sides again. So normally on the right side, it would cancel out and be nice and pretty. And it does for this piece, this x plus 1. But I also have to give that squared out to the 2. So I'd have to do 2 squared. So that would end up being 4. Okay, so if we don't want to deal with fractions, we are allowed to do that, and we could have done that for previous problems. We just have to make sure we're squaring that as well. And then on the left side, again, I am going to do the box. So I do x plus 1 times x plus 1. X times x is x squared. x times 1 is x times 1 is x, and 1 times 1 is 1. So I'd get x squared plus 2x plus 1. On the right side, I am going to go ahead and I'm going to distribute that 4. So I'd get 4x plus 4. And now I'm going to move everything to one side so I can factor and solve. So I'm going to subtract 4x. And I'm going to subtract 4. So I'd get x squared minus 2x minus 3 equals 0. And again, I'm going to have to do the box in order to factor that. So I have x squared and negative 3. So I want something that multiplies to negative 3x squared, but adds to that middle term of negative 2x. So that's going to be negative 3x and a positive 1x. So out of the first column, I can take out an x. Out of the second is a negative 3. First row is an x, and second row is a 1. I'd set each of those equal to 0 and solve. So my two possible answers are 3 and negative 1. But again, I got to check them both. So I'm plugging back into the original. Okay, so I'm going to say the square root of 2 times 3 plus 3 needs to equal 1 plus the square root of 3 plus 1. 2 times 3 is 6 plus 3 is 9. 3 plus 1 is 4. So it'd be 1 plus the square root of 4. The square root of 9 is 3. The square root of 4 is 2, so 1 plus 4 is 3, so that one's good. And then I'd also want to check 1, or negative 1. So I'd say the square root of 2 times negative 1 plus 3 equals 1 plus the square root of negative 1 plus 1. Negative 1 times 2 is negative 2 plus 3 is going to be the square root of 1. Negative 1 plus 1 is going to be 0. The square root of, 0. The square root of 1 is 1. Square root of 0 is 0. 1 plus 0 is 1. So actually both of these work. So we have two answers here, which we are allowed to have. And that should finish out our lesson for today.